This is lesson number 94, Algebra 1, Uniform Motion Problems of the form d plus d equals n. And let's go ahead and get started here. Up until this point, we have done a couple different types of story problems. One is if somebody goes a certain distance and later on somebody else goes the same distance. We've also done, let's say you ride your bike to McDonald's, distance on your bike, you got a flat tire and had to walk home. Okay, so the distances were the same. So the distance of one equals the distance of the other. Or if you remember, distance equals RT, then we could, instead of write a D, we could write RT equals the second RT. So rate times time, all we did was substituted it in for the D, and instead of D equals D, we got RT equals RT. Alright, so in this particular lesson, we're going to make a little bit of a change, and we are going to take the distance of, let's say you rode your bike, and you were on your way home, and right there you got a flat tire, and then you had to push your bike the rest of the way home. So, distance riding bike plus distance walking equals your total distance, however far that is. Or it could be that you're right here at a coffee shop and your buddy has to go home, and then you decide you need to go home. How far is it between there and there? Okay, so what we're looking at, instead of D equals D, like in other ones, it's going to be D1 plus D2. Or, because RT is the same as D, and that would give you your total. So that's what we're going to look at in this one. Alright, so, makes me laugh. I look at this first example, 94.1, a southbound bus left Fort Walton Beach. I am at Fort Walton Beach, and it says that it left south, and I am looking south, and south is the ocean. So I'm not real sure how you're going to leave Fort Walton Beach and go south in a bus, because there is nothing there but the Gulf of Mexico. But anyway, that's beside the point. Let's look at the story problem and pretend that it's not the ocean. A southbound bus left Fort Walton Beach at 9 o'clock a.m. So here's Fort Walton Beach. And if you live around here, you see it written like this all the time. So the bus heads south. And that is the distance. We're going south. And it leaves at 9 o'clock in the morning. 2 hours later, a northbound bus leaves the same station, and you can go north, leaves the same station, and okay, so this is the northbound bus, and for north. If the buses traveled at the same rate and were 352 kilometers apart at 2 o'clock, how fast were the buses going? How fast were each bus going? Well, it says that they were going at the same speed. So if we find the speed of one bus, we found the speed of the other. Alright, well, let's find what we need here. We need rate in time for the north bus, and we need rate in time for the south bus. Alright, so the rates were the same. This and this are the same. So we can call them, we'll just call them R for rate, since we're not caring about the northbound bus or the south bus. We just want to know, let's just call it rate. So, time going north, time going south. Well, the one going south left at 9 a.m., and that means that we're interested at 2 p.m., so we're interested in time going south being 5 hours, from 9 to 2. Time going north, the bus left 2 hours later than the one going south, and the one going south was on the road from 9 to 2. The one going north was on the road from 11 to 2, right? Because it left 2 hours later. So the north going bus, let's put that down as 3 hours. So that's some information I have there. Alright, so I know that the rate north times the time north plus the rate south times the time south equals this 352, right? So Rn and Rs are the same. So again, let's just call them R, since it doesn't really matter. This Tn here is 3. We decided that. And our Ts is going to be 5. So we have 8R equals 352. So our R is going to be 44. In this case, it's kilometers per hour, and that's our answer. Alright, let's look at the next story problem. A train starts from Toledo. Okay, there's Toledo. Okay. Train starts at 11 o'clock a.m. and heads for Mackinac. Mackinac is in northern Michigan, and it's 332 kilometers away from Toledo. At the same time, a train leaves Mackinac, which is going to be right there, and heads for Toledo. And it is going 65 kilometers per hour. So the one from Toledo to Mackinac went 332. The one from Mackinac to Toledo in red, it gives us the speed, 65 kilometers per hour. If the trains meet somewhere along the line at 1 o'clock, what is the rate of the first train? So our little picture is going to look like this because they meet each other right here at 1 o'clock. This is Mackinac and this is Toledo, and they're going to meet here. So when you add these distances up, you get 332 miles. And what else do we know? Not a whole lot. So we've got the rate to Mackinac times the time to Mackinac plus, no, I guess we don't, do we? We've got, let me say that again. We've got the rate here, let's call this 1, plus this rate times time, we'll call that 2, and that equals 332. Okay, because this one we're interested, this is the distance here where they meet, and over here's the distance here where they meet. They don't go the same distance, but when you add the two distances up, you get the 332. Alright, so let's start filling in our letters. Okay, so we have R1, which we have no idea how fast the train going from Toledo to Mackinac is going. It doesn't tell us. But we do know that he's on the road for 2 hours, okay, because he left at 11 and they meet at 1. The rate of the second train we know. We were given in the problem 65. And time for that second train. Do we know anything about the time? At the same time the train leaves okay, so they're both on the rails for the exact same time. On the rails, that's railroad talk. My brother is a train engineer, and so I can use that kind of talk. All right, so we've got 2 times the rate of the first train plus 130 equals 332. So 2R1 equals 202. Divide by 2, divide by 2, and our rate of the first train is 101 kilometers per hour. Okay? And what are we interested in? The rate of the first train. So this train right here that was leaving here and going here is going 101 kilometers per hour, and this train from here to here was going 65. Okay, 101 kilometers per hour, it's around 60 miles per hour. Alright, let's do one more. Alright, so this is example 94.3, and we've got 2 ships, and they are 400 miles apart at midnight. Okay, so at midnight, the distance between these ships is 400. All right. And they're headed directly toward each other. So if they collide at 8 a.m., so that red ship and the blue ship, they run into each other and everybody gets smushed. If they collide at 8, find the speed of both ships if one was 20 mile an hour faster than the other. Alright, so we're going to call one of these ships well, let's call one the fast ship and one the slow ship, because one's going to be going faster than the other. It doesn't really matter which one you call the fast and which one you call the slow. But we do know that the distance of the fast plus the distance of the slow is going to be 400. So R of the fast, T, plus R of the slow, T of the slow, equals 400. So this is a key thing when you're doing these. Make sure your distances, if you're adding them, change them to RTs and RTs. Alright, so let's fill in the blanks with what we know. The time of the fast ship we know is 8. The time of the slow ship we know is 8, because they left at the same time. Okay, because it was at midnight and they're headed toward each other, and it was 8 o'clock in the morning when they run into each other. So let's look at our RF and our RS and compare those. What do we know? We know that the fast ship was 20 mile an hour faster than the slow one. So the fast one was the speed of the slow one plus 20. So what we're going to do here then is we're going to substitute. We're going to put RS plus 20 there, and we'll leave our RS here. And what does that do? That gives us one variable, RS and RS. So we have 8RS plus 160 plus 8RS equals 400. So 16RS plus 160 equals 400. 16RS equals 240. Is that right? Yeah. Divide by 16, and our RS is going to equal 15. Okay, so that's the rate of the slow ship. What do we know about the fast ship? Because we're looking for that speed too. The fast ship is 15 plus 20. So the fast ship is going to be 35. And those are my two speeds. And that's all we're doing for lesson 94.